Okay, we're going to solve problem SAC136-2. And at atmospheric pressure, how much heat does it take to convert 2.5 kilograms of ice, solid water, at 15 degrees Celsius to liquid water at 25 degrees Celsius? So the idea is that we have to find the heat it takes to warm the ice up to its melting point, melt it, and then turn it into water. So the heat that we're looking for, total heat, is going to be equal to the heat needed to melt or to raise the temperature of ice from 15 or negative 15 degrees C to 0 degrees C. We're going to add that to the heat needed to melt the ice, and then add that to the heat needed to raise the water from 0 degrees C to 25 degrees C. I'm going to use the term water for liquid water. You could write that as an equation using Q for heat equal to, I'll call this one Q1, the melting heat Q2, and the heat needed to raise the water temperature to Q3. Q1 is we're gonna use the specific heat idea, MC1 delta T1. The mass times the specific heat times the temperature that it reaches minus the temperature it started at. Initial and final. So if I plug those in, the mass is 2.50 kilograms. The specific heat of ice is 2100. This is joules per kilogram degrees Celsius, and the final temperature is going to be 0 degrees, and we're subtracting off the negative 15 degrees. The final for that, multiplying those together, is 78,750 joules. To do the heat it takes to melt the ice, we use the idea of latent heat, which is just proportional to the mass. The mass is the same, 250 kilograms. The latent heat of fusion for ice, to melt it from ice to water, is 330,000 joules per kilogram. And so those just cancel out, which leaves 832,500 joules. Up here I didn't do the units. The units also come to joules. The third heat that we need is to raise the water from the 0 degrees it is at this point. By adding this heat, we didn't change any temperature, we just changed it from solid to liquid. But we still have now the same mass, and we're going to see the new temperature change. So I'll write this as I did up there. MC3, temperature final 3. So here we're going to go from, we have a mass of 2.50 kilograms, a specific heat for water of 4186 joules kilogram degrees C. We're going to have a temperature change. We're going to end up at 25 degrees C, and we started at 0 degrees C. Units again, the kilograms cancel, the degrees C cancel. We'll be left with joules, and the answer is 261,625 joules. We will take those individual ones and add them up. And putting in the values that we computed above, for each of the different Qs, to give a total of 1,172,875 joules. Just keeping 3 significant figures, 1.173 times 10 to the 6 joules, 1.17 megajoules.